Two-wire splices. When maintaining a two-wire system, maintaining the health of the two-wire path is a critical part of the management. And nowhere is it more common for a two-wire path to fail than right where we've spliced that wire to add to the two-wire path. In fact, I estimate as high as 90% of the support calls that are generated from two-wire sites end up not only being a problem with the two-wire path, but specifically in a place where splices exist. The good news is, if we take our time and do these splices properly, the rate of failure drops significantly, and these systems become significantly easier to manage. So if your two-wire has a happy splice, it has a happy life. That's why in today's training we're going to focus on this one specific thing about two-wire: how to make proper two-wire splices, and the tools, materials, and processes involved in making a correct two-wire splice the first time so that it doesn't wear out quickly and increase wear and tear on the two-wire system. To begin with, in this video we'll discuss cutting into the two-wire path, but that is something we would never do if the two-wire path is plugged in, because there's constant voltage on there and you can not only hurt yourself but damage important controller components. So always disconnect the wire path from the controller before you cut into the wire. Let's begin by talking about the two-wire path itself. What we are looking for is a jacketed pair of solid core irrigation wire, generally 14 gauge. WeatherTRAK is wire agnostic, so whether you have maxi cable, Toro decoder cable, or Hunter decoder cable, you'll be compatible with the WeatherTRAK system. And regardless of what cable you have, you always have to be careful with how we treat the two-wire path. And this wire jacketing is an important part of protecting that two-wire path out in the landscape. So you'll have these two sprinkler wires wrapped in this jacketing. Buy your wire directly from Page. You can specify not only the gauge of the wire, but the color of the jacketing, so that you can make every two-wire path on your site a different color and make it easy to separate things for troubleshooting down the road. So managing that jacketing is an important part of the conversation, because that jacketing is our first line of defense. And as you can see in this picture, sometimes even the jacketing isn't enough to deter pesky rodents. And it's important that we know how to manage this jacketing without damaging the wires underneath. Too often I see irrigation installers using their wire cutters to start this jacketing, or even worse, their pocket knives. And when they do that, they risk damaging the wires underneath. So if you look both at this photo right here, you see the blue wire has been hit all the way down to the copper when peeling back the jacketing for the connection just above. Or if you jump way over to this top corner, you see another example where this black wire has been hit all the way down to the copper while the installer was cutting back that jacketing. So properly peeling back the jacketing is the first step of making a proper two-wire splice. To do this, we would recommend using a tool that's specifically designed for the task of cutting back this jacketing. For today's example, I'm going to use a tool that I lovingly call the potato peeler. And while this is not the only tool that's designed to cut through this jacketing, it is definitely not your old wire strippers or your pocket knife. And in today's demo, we'll see that using the right tool is not only essential, but it's easy. So you see here that I've got a jacketed pair, and I've got one red irrigation wire and one black irrigation wire inside of a red jacket. And I want to peel back that jacketing off of the red wire. So I set the whole wire into the wiring harness, and I push the device far enough back that I can expose some wire. So I put the jacketed wire in the potato peeler, then I apply pressure and pull back, and the potato peeler will pull off a strip of that jacket without ever touching the wires on the inside. And in my experience, even using the potato peeler, you can sometimes put enough force on that wire to cut that inner jacketing on the irrigation wire. So I recommend using the potato peeler to start the process of pulling back that outer jacketing. And once I've exposed the wires underneath, I'll pull back the ripcord and expose all the wire that I need to make the proper connection. That way, if I do inadvertently hit that wire underneath, I can easily cut back the compromised section of wire and leave only the good protected wire for our two-wire splice. And while we're on the subject of the two-wire path, it's best to remember that a little basic wire management can save you a ton of time and headaches when managing a two-wire system. First, whenever you're cutting into the two-wire path, you want to beware of bad wire. Especially for the folks managing the system out in the field, it's important to know that the constant voltage on that two-wire path will increase the speed that a bad connection will wear out. And so when you're managing that wire, you always want to be vigilant about looking for corroded wire or black wire, and make sure that when you're making a two-wire splice, only good wires go into the connection. Both installers and maintainers should keep in mind the future testing and repair of the system, And make sure that any splice on that 2-wire path is protected in a valve box and has easy access for future testing. Remember that any place we cut into that wire or add a splice is a point that we will need to test down the line. We also encourage you to make a map, or better, use the mapping in WeatherTRAK Mobile to mark all of the boxes where splices exist to make it easy to come back and find and test those points in the future. And when installing or maintaining, you want to make sure that there's enough wire in the valve box to manage any future testing and repairs. I always like to make sure that the wire is long enough that we can get those connections out of the box for the required testing. That makes it easier to manage the splices and the testing. Some of my techs like those wires long enough that they can pull the wires out of the box and stand up while doing all of the testing. So they prefer the wire to be long enough that they can bring the connections up to a standing hip height above the ground level so they can easily test the system. And once we've exposed the 2-wire path from the jacketing, the next step is to splice in the devices along your 2-wire path. That is to say, if you want to add any device to your 2-wire path, every device needs a 2-wire decoder. And a device is anything you want to add on to that 2-wire path, like irrigation valves or flow sensors or grounding points. So any place you touch that 2-wire path, you're going to splice in a decoder first and then add your device. And every decoder has multiple splices. So anywhere this happens on your system, you're going to have multiple wire splices that you need to install and manage. Every electrical connection along the 2-wire path will be protected in a 3M DBRY-6 or equivalent wire nuts. This will keep all of the water and contamination away from the copper and ensure this connection for years to come. Any equivalents must be rated for direct burial, and the gel inside must be rated for a minimum of 600 volts due to the constant voltage on the 2-wire path. And not using the correct connectors is the most common reason that I see these 2-wire paths fail. And this slide is full of examples. Let's start here, where this connection is made with the standard irrigation wire nuts. The constant voltage on the 2-wire path will melt out the silicone out of those wire nuts, and they'll be as good as electrician wire nuts in a year. And here we see a system that used the DBR wire nuts, but didn't put the wire nuts in the silicone caps. So as soon as water got in that wire nut, it caused a short on the 2-wire path. Or even worse, here's one that just got stripped together and didn't get put in a wire nut at all. Once you've got the outer jacketing stripped on both sides of your wire, the next step is to strip back the inner jacketing off of each wire individually and get it ready for the wire nut. This is where we'll use our wire strippers, where you'll notice that by using the numbers on the head of the strippers, you can cut to a certain gauge of wire, which will cut through the inner jacketing but still leave the wire untouched underneath. And once your irrigation wire has been stripped back, it's time to make the connection to whatever 2-wire device you're adding. This will begin by properly connecting the decoder. The wires for our decoders come pre-stripped, so once you've stripped back the irrigation wire, you'll take the wire from the decoder and line up the jacketing from the stripped back wire with the end of the jacketing on the decoder. Then you'll use your wire cutters to cut all of the wire to the same length. As a rule of thumb, I use the wire nut to determine the length of the exposed wire, so that all of the wiring fits nicely into the wire nut without leaving any exposed underneath. At this point, it seems common that irrigation guys will twist these wires together before putting them in the wire nut. However, twisting these wires together can add additional stress onto the wire, and in some cases break that wire underneath, causing this entire connection to fail. By design, the wire nuts connect all of these wires together without the need for twisting them up, so we recommend cutting them to length and putting them in the wire nut without twisting them together. However, once they're in the wire nut, we screw that wire nut down until it's tight, and then give a tug to each wire in the connection to make sure that it's held tight in that wire nut and all parts of the connection are secure. A couple of things to keep in mind, or tips for making a successful connection, is that first, our DBRY-6 connectors are designed for a maximum of 3 wires. So you'll have your 2-wire path coming into the valve box, the decoder wire, and the 2-wire path that leads out of the box or onto the next connection, so you'll never have more than 3 wires in any single wire nut. However, it's not uncommon to have only 2 wires in the wire nut, so with DBRYs it's okay to go less than 3, it's just never okay to go more than 3 wires at a time. Also remember that the 2-wire path is polarized, so it's important to always stay color consistent, and throughout the entire system that the black and red wire on the decoder always stay connected to the same color on the 2-wire path. In this case, since we have a black and red wire, we'll always go black to black and red to red. Once you've connected all of the wires for your first connection, you'll do the same for the other decoder wire and the 2-wire path. And then you'll connect your field device on the other side. In this case, because we have a valve, you'll connect each of the valve wires on the decoder to one of the wires coming from your valve solenoid. And once you've accurately put all of these wires together, the electrical connection is complete, although the 2-wire splice is not complete. However, if you're troubleshooting, this is a great time to go test that connection from the controller. The reason we recommend verifying your connection now has to do with the 3M DBRY-6 connection. Not so much the wire nut, but the polypropylene tube that we'll use to waterproof this connection by submerging that wire nut into the moisture-resistant grease. It's important to understand that these tubes are not reusable, so you want to be 100% sure that that connection is sound before you submerge it in that grease. It's also important to remember that we would never be cutting into or dealing with the 2-wire path that's plugged into the controller. Remember that there's constant voltage on that 2-wire path, and cutting into a live wire can not only result in personal harm and put you in danger, but cause damage to important system and controller components. And once that electrical connection is complete and tested, and you're sure that each wire connection is the way that you want it, it's time to complete that 2-wire splice by completing that DBRY-6 connection. Now, submerging that wire nut into the grease is not difficult, but it does take proper technique to get it done correctly. So first we pop the top on the tube. To do this, we unlock it from the tabs and pull back the top like a hinge. And you'll notice the hole in the tube has a very specific shape. Now we look at the wire nut and you see the wings on the sides of the wire nuts. These wings will fit into the slots on the tube like a puzzle piece, so everything fits together very nicely. So after our connections are securely in those wire nuts, we'll take the DBRY plastic tube, open it like a hinge, fit the wire nut like a puzzle piece inside the plastic tube, then push that wire nut through the dielectric grease until that wire nut reaches the very end of that plastic tube. And only by completely inserting that wire nut into the plastic tube does the DBRY work the way that it's supposed to work. Because by pushing the connection all the way into the plastic tube, we'll displace the grease inside the tube, and it will come up around that wire connection and seal out any water or other contaminants that might affect the electrical connection. And just like you see in this example, if the wire nut isn't completely inserted into the plastic tube, then we don't displace enough of the dielectric grease to cover that connection and to seal out those contaminants. And this type of issue is especially sad because the installer really did think they were doing the right thing and using the right product, but by not pushing that connection in the last half an inch, they created a situation where water can affect the 2-wire path. A few things to keep in mind for making a well-protected electrical connection with a DBRY-6 connector is, first of all, never put more than 3 wires into a single connection. If you have a connection that has more than 3 wires, we recommend breaking that into multiple DBRY-6 connections, so we're not overstuffing these wire nuts and compromising the electrical connections. Secondly, be careful you strip back enough wire to make the connection thoroughly without stripping back too much. Ideally, you'll leave enough length in the wire to make sure that the wire nut reaches the bottom of the tube, and there's enough extra wire at the top of the cap to make sure that that cap closes and those wires safely go into the channels in which they're designed. And you want to leave enough unjacketed wire below the DBRY that down the line you can easily separate those wires and wrap your milliamp clamp meter around each wire individually. So you want to leave some wire exposed from the jacketing for measuring and management, but you want to make 100% sure that any wire that is outside of that DBRY is protected by that wire jacketing, and there is no nicks in the jacketing or worse, exposed copper. So you don't want to expose too little wire that you don't have enough room to make the connection, but you also want to be cautious about any wire you leave exposed. Also, when using the DBRY-6s, sometimes the dielectric grease inside gets to be very thick and hard to penetrate with that wire nut. A good trick to know is that that dielectric grease is temperature sensitive, and so it will soften with heat. My most experienced guy actually carries a heat gun to heat up the dielectric grease inside the tube. But others I've seen use the concrete or asphalt, leave it in the sunshine, and that will warm it up enough that the grease inside softens up a little bit. Also, installers swear by the body heat method, and keeping them in your waistband or under your shirt heats the gel up enough to make it malleable. Then when the wire nut is at the top of the tube, you want to close that tube and make sure that you put all of the wires into their channels. There's a lock on the top so that the tube seals up when you're done. Make sure that that tube gets closed and locked in place. And then when you're putting it back in the valve box, take those tubes and make sure that they're pointing at the sky before you close the valve box. Just setting them vertically in itself is a way of protecting the connection from contamination. And last but not least, it's important to know that these DBRY connections cannot be reused. Once you've sunk that wire nut all the way into the dielectric grease, there's no going back. Because as seen here, when you remove that wire nut from the polyethylene tube, most of that moisture-resistant grease comes out with that wire nut, and there's not enough dielectric grease left in the tube to cover a wire nut a second time. So anytime you remove the DBRY-6 connection, you have to use a new one to replace it. Furthermore, it only takes one person managing the site before you that doesn't know this to have it happen multiple times across the site and compromise many connections along your two-wire path. That's why it's a good idea to make checking these electrical connections a part of assessing a two-wire system and replacing any connection that seems suspect of not having enough dielectric grease to cover the electrical connection in your DBRY-6 connection. Again, I would estimate that of all the calls that I get to support WeatherTRAK two-wire, at least 90% of the field issues come down to a bad two-wire splice along the two-wire path. That's why I think that the two-wire splice is the most important subject to talk about in two-wire training for either installers or maintainers. Because if you have a happy splice, you'll have a happy life with two-wire. To say that a different way, when all of your electrical connections are made to spec, two-wire becomes very simple to manage and almost trouble-free. But on systems where the electrical connections are suspect, two-wire can be a nightmare that seems to produce one electrical problem after another. So I encourage all contractors to create a very high standard of what they expect out of a two-wire splice and make sure that their standards are met on all of the systems that they install or maintain.